Yes.
All right. It is Wednesday, January 12th. Today we are talking more about these digits and numbers in the thousands, 10,000s, 100,000s, things like that. We have some people online with us today that were not here yesterday. So we're going to do this very quick because yesterday we did it like big time. And so if you weren't here yesterday, or when I teach today and you're like, I don't know what she's talking about, go back and watch video 5. Video 5 is a really good review of what we're talking about right now. So if you were absent or if you're struggling with this review slide, you really should go back and watch video 5, okay? Here's what we talked about at the beginning of video 5. What is the value of this model? Anyone? 1. If I have 10 of these, that makes a 10. If I have 10 of these, that makes a 100. And this is called a flat. If I have, oh, this is more than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, yeah, that's 13. If I have 10 of these, that's going to get me a 1,000, which is a cube. And we decided as a group that the size of this cube was close enough in size to these tissues, right? And so, if I have how many tissue boxes?
10.
10 of these. So we're going to do it this way. How many is this? 2. 1, 2. 3. 4, 5. 6. 7, 8. 9. 10. What's this called again? A cube.
4,000.
It's the value of this cube is 1,000. How many thousands do I have here? 10. So that means this is called a 10,000, a big long. It's a tall, this is 10. This is 10,000. And yesterday we talked a little bit about what if I had 10 of these longs? That would make 100,000. And what would the shape of that be?
A rectangle.
A big flat. Think about it. You're taking these longs and you're standing them up next to each other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a big flat. That and the value of that big flat is
10,000.
this is 1,000. This is 10,000. If I have all these, it would be 100,000. What if I had 10 100,000s? It would go flat, 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 and it would make a big cube, which would be
1 million.
1 million. Very good. That's what we talked about yesterday. Really briefly. Wow. We talked about it big time yesterday. So if you want to learn more about that, or you want to have a more focused review on that, video 5. Okay? Go back and watch video 5. Some of you, I want you to watch video 5 no matter what. You need to go back and watch video 5. Okay? Okay, so now that we have that understanding, how many thousands are in this number? How many thousands, Aiden? Oh, wait, Will asked if he could share out, and I told him yes. Go, Will, sorry.
Thousands.
Huh?
57.
We have 57 thousands. But hey, Will, I got a question. The 7 is the digit in the thousands place. So I'm kind of thinking that this should just be 7, not 57. What do you have to say about that?
Well, it's in the thousands place, but we have more than just 7 of them.
Because even though we have 5 10,000s, all of those because this 5 would be a 10,000, right? All of those 5 10,000s are all made up of these, right? So do they still have to count? They do. They still have to count. You still have to keep that 5 on there for, 57. Good job. Next one, Will.
How many 10,000 is 5? Because 10,000 would be 0, 0, 0, 0, 0, 1. 10,000.
Hold on.
So it would be 1, 0, 0, 0, 0 for 10,000s, but there's 5 10,000.
Okay. Good. And then write the number in words.
7,000.
57,000. Now, I want to talk about this for one small second. 57,000 is our number, right?
Mhm.
This is the reference sheet you are going to take on your Ohio State test, which we call the AIR test. And when we talk about AIR test, there is no fear, worry, dread, doubt, or nerves, right? Not to get butterflies like you do before a big game. We're not going to be worried that anything bad's going to happen because nothing bad's going to happen, right? Right. So we're not going to worry about that necessarily. Now, I want to use this number, 57,000, and I want to use this chart. How many ones are there in 57,000? Everybody say it together.
0.
Tens,
0.
hundreds,
0.
thousands,
7.
7 in the thousands place, and then 10,000
5.
would be 5. The name to today's game is using the place value chart. If I ask you to write the number 57,000, you're not going to write this. Because that's the number 57. What if I ask you to write the number 57,003? 57,003. Is that going to be my number like this? No. How many hundreds are there in the number 57,003? 0. So do you have to write the 0 to hold that place? Yes. 57,000. No hundreds. No tens.
No 3 1.
3 ones. Here is what I did not tell the last class well, but I'm going to tell you well, and I'm going to record well. Every section of a number has how many digits?
0, 10, 9.
Nope. 5. Here's a section.
3 and then 2.
3. This one has 2, but can I put one more here?
Yes.
What if I change this number to 457,003? How many digits are in this section?
3.
3. Then I would have another comma here. And then I could
Go to the million.
go to the millions, 10 millions, 100 millions.
Then trillion.
What's this how many digits are in this section?
3.
3. That is what you need to remember. When you're writing a number, each individual section has 3 spots, and you have to fill in all 3 of those spots. And if you have a number, so let's say 103,002. 103,002. 103,002. That's what you hear. But what number is this? 132. Now it's not 132, is it?
Yeah.
No, you ain't going to say that and word. It's just 132. But I'm looking for the number 103,002. 103,000. 1,000 is when you get the comma, right? And 2. How are we going to do that, Garrett?
You're gonna have 2 zeros because there ain't no hundreds or tens, and then there's 2.
Very good. This is, you need to think about this. You need to consider there are 3 each little section. It has a fancy name, but I can't think of it right now. Each section has 3 digits in it. And if you don't have some tens, you have to write that as a 0. You really need to consider that today for today's lesson, okay? Okay, here we go. I like today's jumping start. It's a fun one. We're going to be talking about the same digit and a different value. Let's describe the relationship between digits and multi-digit numbers, shall we?
Yes, we shall.
Before we do that, I want to do a little bit of ELA. What's the difference between a digit and a number? A digit and a number. So, like, if my number is 146, what's the difference between the digits in that number and the number itself? Nikki?
The digits are the numbers that are in it. Like 6, 4, 1.
Okay, so these are the digits. This is a digit. This is a digit. This is a digit. Is that what you're saying?
Yeah.
These are the digits. What is the number? What does that mean? What's the number, Will?
The number is like a full sign, like.
The number is like the whole thing, right? How do we explain that in words? We didn't really say that in words. We just said that like we drew a diagram, which you know I'm all about the diagram. That's fine. I'm fine with drawing a diagram, right? But what does that mean? Like, can we make it in words? Charles?
147 is numbers because it's you can just say it in a whole word.
Okay.
And digits I can't say it right. Is the number that's like the placement. Like 1 is the digit for the ones place.
The 1 is the digit for the hundreds place.
Yeah.
Right? So the digit is the place on the chart. Does that make sense?
Mm-hmm.
So if we had like a place value chart, the digit is the place on the chart. What's the value of the 4 here? Everybody?
4, 10, 4, 10, 40.
Huh?
40.
40. We have a 4 in the tens place. So there are 4 tens. The value of the 4 is 40. What's the value of the 6? 6 ones. So the value of the 6 is just 6. What's the value of the 1? 100, because
It's in the 100 place.
it's in the hundreds place. Now, can we change the value of the 6? Can we change the value of the 6? How would we do that?
You can add a 1. That would be the only way to change it, because if you add a 10, it would just be changing the tens place, and you add 100, it would just be changing the ones place. Or yeah.
Okay. Gage, what do you think?
If you add 4 to the 54, then there will be another 1 and 10, and then there will be a 0,
So are you all saying that if we moved the 6 to a different place on the chart, then it would have a different value?
Yeah.
It would still be a 6, but it would be a 600 or 6,000 or a 60, right? So can we change the values of the digit by moving them around? Yeah, we can always change the value of a digit. We can put it wherever we want or wherever they want us to. Can we change the value of a number?
Yes.
Yes.
Yeah, because you push plus. Add.
Right, but then you're creating a new number. Are you ever going to change the value of 146?
No.
146 is always going to be 146. Because if you change the digits around, now you have a whole different number. Right? So the value of a number cannot change unless you're changing it into a whole new number. So if you have 146, it's just always going to be 146. See what I'm saying? Does that make sense? All right. We need to make sure we know the difference between a digit and a number. The digits are what make up the number. The number is the whole thing. We can flip these around to create a new number, use the same digits in different places. That changes the value of the digit, but we can never change the value of the number because if you change this, let's switch these. Now it's not the same number anymore. Understand what I mean? We can't change the value of the number. That value of the number is always going to be the same. So let's decide if each statement is true or false. Here we go. If you're online, raise your hand, click the button, and I'll call on you. Levi, true or false?
It's false because you already have 70,000 and 4,000. If you would add that, that'd make 11. So that would make an 11 onto the 70, which would make it 81.
Now, hang on a second. You're not going to add the 7 and the 4 because this 4 is in the thousands place. So it's just going to go right in that thousands place. Yeah.
And then if you added the 600, it would be 74,600.
Good job. Everybody agree with Levi?
Yes.
All right. Next one. True or false? Lots of 8s and lots of 0s, huh? Nikki?
False.
Why do you say false, Nikki?
8 plus 80 plus 800,000 equals 800,088 and
88,800. You got an 8 in the. You got an 8 in the tens thousands. Then you'll have an 8 in the thousands, and then you'll have an 8 in the hundreds. 8 in the 10,000s, 8 in the thousands, 8 in the hundreds, and then your 2 zeros. And so this is going to be your number, and this is already a miss, right? It's already a miss. Good. Next, well, and finally, this is the last one. Ella?
true
True? Why do you think so?
because 900,000 plus 20,000 equals 920,000. And then if you add that to 3,000,
So what we've done here is we've taken this part and made it match up with this part. And then these parts matched all along, right? So do we need to find the value? Do we need to find the value to know if they're equal or not? We do not need. So here, how can you explain your answer without finding the value on both sides? We did that with the third one. We could have done that here because 80,000 and 800,000, we had 808. Is there any way that these three numbers were going to get close to 800,000?
No.
No, we didn't really need to find the value. We did, and that's fine. But we didn't need to. Same here. This is a 4 in the thousands place. Does this have a 4 in the thousands place? So do we know right away that it's false? We know that right away. We don't have to go any further to figure that out, right? We can write numbers in different forms. What form is used to represent the numbers in this true or false? Do you remember what this is called? When you write numbers as in like addition problems? Nikki? Nope. Garrett?
A fraction?
Nope.
No, wait.
Charles?
7,000 plus 600 plus 70,000.
Right, but that's not true. That's false. What form is used to represent the numbers in this true false? What is it called? Garrett?
Sum?
No? Starts with an EX. X.
Explanation.
Expression.
Expression. These are expressions. You're right. They are expressions, but that's not the word I'm looking for. Somebody said that earlier today. Not expression. Expand.
Expanded form.
Expanded form. Who has heard that term before? Expanded form. Good. We're going to be talking about that today. All right. In the classwork section of your notebook, we are going to fill this out. And so those of you that are watching this on a recording, this is where the recording gets kind of a little bit strange because the remainder of our class is going to be heavily in group work. And I have so many students that are out today on my Google Meet that I have to use this computer. So what I want you to do, if you're online, I want you to pause right now and fill out this chart. I want you to fill out this chart using expanded form. Make sure that you hold the place for the zeros. So go ahead and pause and fill out this form. Just wait. Okay. Now that you've unpaused and you're back, now we're going to talk about these questions together. Choose two numbers from the table to make this statement true. So you're going to go back to the table that you just made. You should have done this on loose leaf paper. My class students should have done this in their cactus notebook in the classwork section. You're going to go back to this chart and you're going to find any of these numbers that you wrote and find a 3. The 3 in, and then you're going to write that number here, is 10 times the value of the 3 in. You're going to find a number that has a 3 that's 10 times the value. When we're talking about 10 times the value, remember that in the ones place, you have this. In the tens place, you have 10 ones. So 1 times 10 equals 10. So this digit's going to be 10 times the value of this digit. So if I have 2 of these times 10 would give me 20. So the 2 in the 10 space is 10 times the value of the 2 in the ones place, because 10 of these gets me 1 of these. Okay? That's what it means when it says 10 times the value. And then I want you to explain why you chose those numbers. And if you're watching this recording, you can't really do number 6. Okay? And so Today, when we finish this lesson, we're going to be able to describe the relationship between the same digit in different places in a multi-digit number. So if we have the number 237 and the number 425, the 2 in the hundreds place is 10 times the value as the 2 in the tens place. Because when this 2 moves over to that hundreds place in this number, the value of this digit is 200, and the value of this digit is 20, which is what we're talking about today. And that's what we're going to be talking about when we fill out this chart. So this is the part that if you're watching the recording that I want you to kind of think and ponder on as we wrap up this lesson. What equation could we write to show how many groups of 80,000 there are in 800,000? And that is the conclusion of our recording. So those of you that are still in class, just hold on a second. We will stop this recording. Thank you for watching. Come again. Have a wonderful day, evening, month, year, life, all those great things. We're going to stop our recording now.